Hello, I welcome you all to this another interesting screencast. And the problem reads: the scale is constructed with a 4 feet long cord and the 10 feet block, 10 pounds block D. The cord is fixed to a pin at A and passes over two small pulleys. Determine the weight of the suspended block B if the system is in equilibrium when S is equal to 1.5 feet. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a system here of connected pulleys, a cable going over two pulleys, supporting two blocks. The weight of one block is given, which is 10 pounds, block G, and the block of and block B is not given, and that is what we're being asked to determine. All right, so let's write down the assumptions first. One, we have a single continuous code. Okay, we are assuming that there is no friction between the two cords, the two pulleys, and the cord. Okay, and then we are also assuming that we neglect the sizes of the pulleys. Okay, you can think of these sizes as just points, okay, dots, and so on. When it comes to calculation of the length of the cord and so on, neglect the sizes of the pulleys. So let's draw the free body diagram for now, and then we'll continue with our assumptions. So the weight of this cable here, is given. The weight of this cable here, which we are just going to call W, is not given. And then we are going to section these cables like so. And then when we do so, of course, we expect a tension force like so. Another tension force like so. Okay. Of course, assume that they are all going to the same point. So we have the tension force. These points, I mean this. I am saying we neglect the sizes of these pulleys. Think of these are just dots. So we're going to have tension forces like so. So this one is given, it is 10 pounds, sorry. It's 10 pounds, right? Yes. And then let's say this one, we call it W. All right. Then let's call this T. And because of symmetry, there's symmetry. There is symmetry. Let me write down something here. Symmetry exists through the vertical axis that goes through block B. So we have symmetry about this axis here, right? See that? Okay, we have symmetry, and because of that, we expect these values t to be the same. Okay, and Due to, let me just draw a small line here, sorry. We said that we don't have any friction between the cords and the pulleys. Therefore, we expect the weight of the block to be equal to T. So we'll say T itself, therefore, T is equal to 10 pounds. It's the same throughout, right? This is going to be the same throughout, like so, because it's a continuous cord. So it will carry the same tension. Is that fine? Great. So now let's define the slope. This one there, this like so, like so, like so. All right. So what we are going to do is, let's get this information and transfer it. Let's get this information and transfer it here. All right, let's draw this here. So we have something like this. Okay, something like this, something like so. Great. So we know that half the length of this, because of symmetry, we expect this go through like so. Okay, let me dot this like so. So there is symmetry along that line. Okay, so we expect this here to be equal to 0.5 and this one 0.5. Therefore, this is going to be equal to 0.5. And then we've been told that the total length of the cord is equal to that is length is equal to 4, right? So A, B, C, D is equal to 4 feet. So length A, B, C will be therefore equal to 4 feet minus S. And we know that S is equal to 1.5 feet. Therefore, LABC is going to be equal to, when we do the subtraction, this gives us a 2.5 feet. Therefore, the length LAB is going to be equal to the length LCB or BC, which is just equal to LABC divided by 2, which is equal to 1.25, right? That's 2.5 divided by 2, 1.25. Great. So we have this side here, this length, the hypotenuse is 1.25, right? Okay. Then this other height there, we can use Pythagoras theorem. So it will be 1.25 squared minus 0.5 squared. So let's work out that. 1.25 squared minus 0.5 squared. Oh, great. So this of course gives us root of 1.3125. So this is here 1.3125, right? 0.25 squared minus 0.5 squared. 131.25. Okay, so once we have that, then we can now indicate our component. So we are going to have one component like so in this direction and another component like so in that direction. Okay, then we'll have another one in that direction and another one in that direction like so. So let's label them. So this one is going to be equal to, this one is equal to t times the run, which is 0.5 divided by 1.25, and so is this one. This one is also t times the run divided by 1.25. This one is t times this one, let me write it somewhere. So this one is t times the rise, which is 1.3125 divided by 1.25. Okay, and then this one this one is also equal to t times root of 1.3125 divided by 1.25. All right, so we have all the information that we need and we know what t is equal to. So what we'll do now is we are going to apply the equations of equilibrium. Of course, in the x we know to say there's really nothing there. It is just a 0.5 divided by 1.5. We're just doing it for formality, minus 0.5 divided by 1.25 t equal to 0. There is nothing in there. Let's go to the equation that is going to give us everything. All right, so what we have here, we have two t's, so we'll say 2 times t, there are two of them, okay, times root of 1.3125 divided by 1.25 minus w equal to 0. And we know that T is equal to 10 pounds because we have a continuous cable that is going over the pulley that has no friction between the cable and the pulley, and therefore it is the same weight for block D. That will be the same throughout the whole continuous cord. Okay. So if that is the case, then we are able to find W because we can just replace this T here. We just replace this T there. And once we do so, then we can find W. So grab your calculators, begin to work. So root of 1.3125 divided by 1.25 times 10 times 2. So this gives us W is equal to 18.33 pounds. All right. So we'll say therefore the weight of block B is equal to 18.33 pounds. Okay, so root of 1.3125 divided by 1.25 by 20. Great. So we have determined the weight of this suspended block if the system is to remain in equilibrium, given that S, which is part of the cable CD, is equal to 1.5 feet. So let's just outline the final solution. So we found the weight of this cable, the weight of this block B, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.